Good morning everyone, I'm John Ray Armalata and today I would be demonstrating my CAD modeling process while also highlighting key features and key techniques in using SolidWorks. So this would be a step-by-step demonstration, and the model that I'll be using is located above. So this image is a simple yet illustrative CAD model to work on. So I hope that this video would be a great contribution to the academic community, both to beginners and professionals alike. So before we proceed with this demonstration, I would like you guys to take note that I'm using SolidWorks 2020. So different versions of SolidWorks might appear differently from the one I'm using and might function differently from the one I'm using as well. So just keep that in mind and familiarize yourself with your own version of SolidWorks before proceeding with this video. So, now that we're done with that, let us now focus ourselves to the image above. So, this is a hand wheel. A hand wheel has three major components or three major parts. The first is the hub, then the spokes, and the rim. Okay, so the hub is the center part of this hand wheel. The spokes are the ones protruding from the hub going to the rim, and the rim is the outer part of the hand wheel. So, after identifying those three major components, we can now proceed to the CAD modeling demonstration. So, let's go ahead and do that by clicking on this home button, then clicking part, and making sure that the unit that we're using is mmgs. Okay, so first, let's make use of a rectangle since the image above already has multiple measurements for the hub. So we'll make use of a rectangle, and after clicking that, we would be asked to choose a plane. So I would like to choose right plane. However, as you can see here, the arrows are not normally facing us, or the arrows would not proceed to show us a drawing that is normal to our view. So if we go ahead and draw here, this is what the rectangle would look like. So we don't want that because it would be difficult for us to draw the additional parts of the rectangle. So let's go ahead and undo by using Ctrl Z, and by pressing spacebar, we can change the orientation of our drawing. So we have left, front, right, top, bottom, as well as back. So since I would like to use the right view or the right plane, let's go ahead and click that. And as you can see here, the arrows are now normal to our view. So go ahead and click rectangle again, then simply drag it. It doesn't matter if there's already a measurement on the image, or if by dragging you did not drag it to the correct measurement, since there is a feature here called Smart Dimension, which automatically resizes the sketch by simply having your input, and just like so, it resizes itself to 45 millimeter high. Okay, so the next measurement that I would like to do is the 25 millimeter diameter. However, if we simply click this part, it would not show the same measurement as the one on the image, since the measurement on the image goes further from the rectangle. So what we should do here is delete this and analyze what the difference is from the image and the drawing that we have so far. So the center part or the right side of this rectangle was not considered as a solid line by our image. So this part was considered as a reference line So we can do that by simply changing this into a construction line. So from the options, click for construction, and this would change it into a construction line. Or we can also do this by clicking the line, then clicking construction geometry, and it would give the same result. Now we can proceed by using Smart Dimension again and clicking the left side and the right side, or the construction line, and dragging it to the right. Okay, so simply click that, then modify and go with 25 millimeter. So just like that, we now have two proper measurements for our rectangle. Now, the next thing that I would like to do is the semicircle that is located on the left side of our rectangle. So we can do that by going in this part, the arc, which has a drop down button. So we can simply click the 3-point arc, which is already visible here, but for some of you guys, this might show center point arc or tangent arc. So just simply click the 3-point arc, and then click on the left line of the rectangle. So first click would be something like this. Then for the second click, click on the line once again. That's the second point. And then simply drag your mouse to the left side, and that would give us a 3-point arc. So don't worry if as of now it's not appearing the same as the one on the image, because again, we have a feature called Smart Dimension which would take care of that for us. Okay, so the next step is to trim entities, or to remove this line. We'll remove this line so that we would have a semicircle without a blocking line. So we can do that by simply clicking trim entities, and as you can see here in the options, it is on power trim. So power trim lets us drag our mouse after clicking it, and everything it touches simply gets removed. Okay, so just simply click that, check, and now we already eliminated that line. So the lines that you're seeing right now is the line from the Smart Dimension, so it is no longer a solid line. Okay, so the next part is to identify the measurement from the left side of the rectangle, which is this part, and the leftmost part of our semicircle. So we can do that by using Smart Dimension once again. Click this line, hold shift, then click on the leftmost part of this 3-point arc, and you can let go of shift, then click left click from your mouse, and again modify it to the measurement, which is 4. So we can drag the measurement to the right side or the left side to make it more visible or less cluttered. Okay, so now that we're done with that, let's proceed to the other measurements asked here. So we have a 16 millimeter from this point of the circle going to the bottom point, which is the one I clicked. Okay, so go ahead and make that 16. Okay, so as you can see here, the space from the 3-point arc is different from the space seen in the image. So we have a 10 millimeter space on the top. So we can go ahead and do that by clicking this point and the point above. Then drag it out, left click again, and then change it to 10 millimeter. And just like that, we now have a 10 millimeter space from the 3-point arc. Now, there is a remaining measurement that we haven't done yet. So it is the R5. So R5 stands for radius 5 or 5 radius. So we can do that by simply using the sketch fillet. So this is the sketch fillet. So for some CAD users, they prefer to use the fillet after they turn this sketch into a solid piece. However, I would like to already make use of the fillet right now so that we would not be of risk of forgetting it later on. So let's go ahead and do that. So click sketch fillet, then the sketch entities, click the first one, which is the arc and the line above. Then click the check mark, and that would show a 10 radius. So we can simply modify that by double clicking it, or simply like that, change it to 5. And we can also do that to the bottom part of our 3-point arc. However, it is easier, or it would be easier if we simply just fillet both parts already in one go. So simply click sketch fillet again, line 5, then the 3-point arc, click the 3-point arc again, and then the line below, and change the parameters already into 5 radius. And after that, click check, and our drawing would appear like this already. So as you can see here, we now have an identical drawing from the image above. Okay, so the next step here is to turn our sketch into a solid piece. So we can do that by going to the features and clicking the Revolve boss/base. So click that, close, and it would appear something like this. So I'm able to pan the drawing by clicking the scroll wheel on the mouse and holding it as I drag it leftwards, rightwards, up, downwards, or upwards. So if ever that you want it to be normal to your view, which is the right view, just simply click spacebar again and click the view that you would like to see it on. So we can also go ahead and go with isometric view, and it would appear something like this. Okay, so let's go ahead and click check and observe what will happen. Okay, so now we have this solid piece. So we now have the hub of the hand wheel. So let's go ahead and rename this by clicking F2. So let's change this to hub. So we now have the centerpiece of our hand wheel. Okay, so if you'd like to zoom in and zoom out, just use your scroll wheel. Going downwards would make it zoom in, and going upwards would make it zoom out. Okay, so next, after we made the hub of our hand wheel, we can now proceed and go to our rim first, since our spokes would be going from the hub connecting to our rim. So we should first define the ones that the spokes would be connecting to. So in this case, we proceed with the rim first. So let's go ahead and do that. So in the image above, we have 25 and 30. So 25, which is the height, and 30, which is the width of our rim. So we'll simply do this by going in and clicking sketch and making use of the straight slot. So straight slot, so here we are asked to select a plane or planar face to draw our straight slot. So we can do that by clicking right plane, then clicking our straight slot. Okay, so just draw it somewhere in this part, and then after drawing it, let go, and it would automatically show this oblong shape that you can drag up and down, that would show this expanding oval. So I would simply do this with a blind measurement, and by proceeding again with smart dimensions. So again, this part is 25 millimeters, and the length is 30 millimeters. So we can do that by pressing this part and holding shift and clicking the left part, then modify it into 30 millimeters, and we will now have a sketch for our rim. Then simply click check. Okay, so now we have that. However, it is important to note that there is a specific distance from the center of this hub to the center of our rim. So it is measured as 170. So, and a height space of 6, which is visible in this image. So the height space 6 can simply be made by using smart dimension again, clicking this and the top part of our hub, and it would show the distance or the measurement. Then modify it into 6, and it would move itself just like so. Then next we have the 170 from the midpoint of our hub. For us to properly analyze the center part of our hub, make use of Centerline. Okay, so Centerline is a geometric line or a construction line, so it would not be part of our drawing. So press escape after you're done drawing your Centerline, then make use of smart dimension again, click on the line that you just made, and the center point of that rim. Okay, so it is measured as 170. However, if we look closely in the image, the 170 measurement goes further from the center line again. So it's just like the one we made previously. So the line here is just used as a reference line rather than a solid line. So we can do that by removing this, making use of this point, then clicking the center line and going further away from the center line once again. And as you can see here, it is now showing that the line or the measurement goes further from the center line. then now make it 170, and it's now appearing like the one on the image above. Okay, now that we're done with that, it's now time to make use or proceed with the Revolve tool. So the Revolve tool would make our rim revolve around this hub so that we can create a circle that would look like the one on the image. Okay, so we can do that by clicking on Revolve. Then for the axis of revolution, we'll click the center line, and if you pan it by clicking on the scroll wheel, you can see here that we have now created a circular part that goes revolving around the hub. So go ahead and click that, and it would appear like this. Okay, so again, let's rename this. The name is it as a rim. Okay. Now let's proceed with the spokes. So to make things easier for us, let us change the display style into hidden lines visible, and it should appear something like this. Then let's click right plane and click sketch. Okay, so after we click sketch, as you can notice here, the origin is located at the left part of our hub when compared to the image, which has the origin located at the middle part of the hub. So it doesn't matter as long as we know how to proceed with the drawing. So in this case, to know the middle part of our hub, which would be a reference point or reference line for our spokes, we can make use of a center line. So simply point on the lower part of the hub, find the midpoint, and drag your center line vertically going up. So click check, and from there we now have a reference line for our spokes. However, we still cannot find the exact middle part or middle point of this hub, since there is not enough reference for us to do this. So we can do that by adding another construction line and dragging it across so that it would intersect the first construction line. And as you can see here, there is now a middle point for our hub. Now let's look at the image again. So the sketch of the spokes ends in the middle part of our rim. So to make sure that we can do that, let's go ahead and do what we did with the hub on the rim part. Okay, so drag your center line, and there we now have a center point. So click check and create a new line. So from here, we'll have a horizontal line, and as you can see here, we now have existing relations. So the relations that we have is a horizontal and a coincident. So horizontal because our line is perfectly horizontal, and a coincident since it coincides with the point that we just made using the center line. So we can go ahead and add another relation, which is fixed, to make sure that this line would not move when we make our adjustments using our smart dimension. So after the horizontal line, if you can notice, we have two bended lines. So we'll make use of tangent arc. So tangent arc would look something like this. So That's the first one, and this is the second one. And we'll finish it off with a horizontal line. Okay, so there we go. Now, let us drag this endpoint to the middle point of our rim. So, simply hold that point and find the center point of our rim. And let go. And then click the relation fix. To again make sure that it wouldn't move when we make our adjustments later on. So click check. And now we add our dimensions. So in Smart Dimensions, we have a radius of 29. And if you observe closely, you can see that the first bended line and the second bended line are having equal radius. So we'll go ahead and do that. So in here, we'll click Smart Dimension and 29. And then another 29 for the first bended line. Okay. And there is also an existing measurement of 55 millimeter from this point going to this point. So don't forget that, and go ahead and modify it to 55 millimeter. And now we have a perfectly sketched for our spokes. So go ahead and click check for the dimension, and feel free to pan the drawing to see if we made the same drawing. Okay, so go back to the right view, and then let's go ahead and make this sketch into a solid piece. So click feature, and then let's click swept boss base. So from there, we'll click circular profile and click this sketch that we just made. So in the image above, you'll notice that it is 12 diameter. So we'll go ahead and change this into 12 millimeter. So the preview shows us that this is what it would look like. So feel free to pan it around to see it for yourself, and then simply click check after you're done. And it would look something like this. Now, if you want to remember, on the start of this video, I mentioned that there are 3 spokes that are evenly spaced. So, before we do that, let us first change this into spokes. Like so. Okay. So, to do the 3 spokes that are evenly spaced, we can use the feature pattern, which is located under the linear pattern, circular pattern. So in here, just click equal spacing and click the drawing or the swept boss base that we used a while ago, and that would be for the features and faces. And for the direction, click the hub, and it would appear like this. So it's showing a partial preview, but you can also go ahead and click full preview to see how it would look like. So it looks something like this. So make sure that the equal spacing is selected, then click check. Okay, now we have 3 spokes that are evenly spaced, and to make sure that it looks fine, go ahead and change the display style to shaded with edges, and it should look something like this. Okay, now before we end this 3D modeling process, let us add 2 more features. So in here, we can see the fillet, and we can fillet the inner portion of our rim, and this is that part. Simply click that and use 3 millimeters for the fillet, and then simply click check. It should look something like this. And for the last part or the last feature, select the drop down of the fillet and find Chamfer. Okay, so Chamfer is similar to fillet. The only difference is that the fillet makes use of a more angular cut, while Chamfer is more aggressive and linear. So in here, there are Chamfer types. So we'll make use of distance, distance. So for some of you, the chamfer parameters would be symmetric already. However, I would like to use asymmetric and make use of 4mm for D1 and 2mm for D2. So you can go ahead and follow that. So let's click the top part of the hub, and it should look something like this. Then click check, and now we have a perfectly 3D modeled hand wheel. So if you're not satisfied with its look or its build, we can change that by selecting material, right click, and then edit material. So right now it is steel, but if you like to make it aluminum alloy, for example alumina, you can go ahead and click that, select that, apply, and it would change the material to aluminum alloy, which is alumina. So to check if what you made is similar to the one I did, we can go ahead and evaluate. So click evaluate and then click mass properties. In mass properties, it would show the density, the mass, the volume, the surface area, center of mass, principal axis, and even moments of inertia. So you can go ahead and check that. However, in most cases, we're only just checking for the mass, especially if we're just starting to learn SolidWorks. So in here, what I made has a mass of 1,489.39 grams. Okay, so I think that would be all for this 3D modeling process. So on the left side panel, we can see the three major components or three major parts of this hand wheel: the hub, the rim, and the spokes. For the hub, we made use of the Revolve boss base as well as for the rim. And in spokes, we made use of swept boss base as well as circular pattern, fillet, and chamfer. So I hope that this video is proving to be helpful to you guys, especially to the beginners. So if you have any questions, any comments, and suggestions, you can go ahead and leave them down below. So once again, I'm John Ray Armalata, and this is my 3D modeling process for hand wheel. So thank you for watching and have a great day ahead.